Good morning, students. Today we are going to see the next topic of Unit 5, which is psychrometry. Uh, I hope you have already studied about psychrometry in engineering thermodynamics. So, what is meant by psychrometry? Which is nothing but a science which deals with the study of behavior of moist air. Moist air, in the sense, it is a mixture of air and water vapor. Okay. Atmospheric air makes up the environment in almost every air conditioning systems. Hence, the thorough understanding of properties of atmospheric air and the ability to analyze various processes involving is the fundamental to air conditioning design. So, psychrometry is the fundamental for designing an air conditioning system. In this, you are going to deal with the study of properties of atmospheric air and water vapor present in that atmospheric air, which is called as psychrometry. Okay. The various gases may be present in the air. The air which contains various constant of air, various constant of gas, and then water vapor, we calling it as a moist air. Okay. This moist air can be thought as a mixture of dry air or moist air for practical purpose. The composition can be considered as constant. Okay, the various constant of air are oxygen, nitrogen, argon, carbon dioxide. The molecular weights has been shown in the tabular column. Molecular weight, the mole fraction. So based on the above composition, the molecular weight of dry air is found to be, when you add the above composition, you will get the molecular weight of dry air as 28.966, and the gas constant will be getting 287 joule per kg Kelvin. This is the gas constant for air. Okay, next, this atmospheric air. In this diagram, you can see the various permanent gases present in the air: nitrogen, oxygen, argon, hydrogen. Some dust particles may be present, plus some water vapor presence. After filtration, after removing the dust particle, you will be getting the permanent gas plus water vapor. This makes the moist air for conditioning. Okay. I hope you have studied about Gibbs-Dalton law for the mixture of perfect gas in thermodynamics itself. So according to this law, for a homogeneous perfect gas occupying a volume V and temperature T, each constant behaves though the other gases are not present. So each gas obeys perfect gas equation, that is, the pressure of a gas which will be equal to the partial pressure of other gases present in that gas. If a gas contains n number of various gases, so the pressure of gas which will be equal to the n number of partial pressure of n number of various gases present in that gas. So applying this equation to moisture, you will get the total barometric pressure which will be equal to the partial pressure of dry air plus partial pressure of water vapor. Okay. Next, we are going to see important psychrometric properties. What are all the properties that involved in the psychrometric process? Okay, first of all, it is a dry bulb temperature. It is normally known as dBT. It is the temperature of moist air at the temperature of the moist air as a measure of standard thermometer or other temperature measuring instrument, as a measure of the standard thermometer. Okay. Next one is saturated vapor pressure. It is the saturated partial pressure of water vapor at the dry bulb temperature. So the saturated partial pressure of water vapor when it is at dry bulb temperature is called as saturated vapor pressure. It is normally denoted by Psat. This is readily available in the thermodynamics tables. Okay. Next thing, we are going to see relative humidity. It is defined as the ratio of mole fraction of water vapor present in the moisture to the mole fraction of water vapor in the saturated air. It is nothing but relative humidity is the ratio of partial pressure of water vapor, mass of water vapor in a given volume, to the saturated mass of water vapor in the same volume. So partial pressure of water vapor to saturation pressure of pure water vapor at the same temperature, or mass of water vapor in a given volume to saturated mass of water vapor in the same volume of the temperature, which is known as relative humidity, is normally denoted by phi. Okay, next one is humidity ratio. You may have a notation omega or W. The humidity ratio, which is also called as specific humidity, which is also called as specific humidity or moisture content. It is the ratio of mass of water vapor to the mass of dry air in the given volume. Mass of water vapor associated with each kilogram of dry air to the mass of dry air in the given volume. So how much amount of mass of water vapor present in the water vapor present to the given volume of dry air, which is usually denoted by mv by ma, mass of water vapor to mass of dry air. Solving the equation for mv will be written as pv equal to mrt equation. So for mv, partial pressure of water vapor, volume, water vapor constant, temperature. So we'll getting, after solving this equation, we'll get pv by rv divided by pt minus pv by ra. So after substituting the value of ra and rv, we get the value of 0.622 pv by pt minus pv. Either it may be denoted as pb, barometric pressure, or pt, whichever convenient you can see. So pt is the given barometric pressure. Either it may be denoted as pb or pt. Okay. Next we are going to see dew point temperature. So the dew point temperature is if unsaturated moist air is cooled at constant pressure. If the moist air is unsaturated, when it is cooled at a constant pressure, then the temperature at which the moisture in the air begins to condense is known as dew point temperature. The temperature at which air begins to condense in unsaturated moist air is called as dew point temperature of an air. Okay. Okay. Next, degree of saturation, which is denoted by mu. The degree of saturation is the ratio of humidity ratio to the humidity ratio of saturated mixture. Ratio of humidity, specific humidity of moist air to the specific humidity of saturated air, omega by omega s. Okay. So the enthalpy of moist air is the sum of enthalpy of dry air and enthalpy of water vapor present in the moist air. So the enthalpy value is always based on some reference value. So it is denoted by the equation H equal to HA plus, where W is the specific humidity or humidity ratio, okay, plus into Hg. You may have the formula Hg equal to H of G plus CpWT. Cp is the specific heat of dry air at constant pressure. Cpw is specific heat of water vapor. T is the dry bulb temperature of air. W humidity ratio. Ha enthalpy of dry air temperature. Hg enthalpy of water vapor at temperature. Hfg latent heat of vaporization. The unit of Hg is kilojoule per kg of dry air. Okay, when you substitute the value of Cp and Hg, you will get this equation. Okay, next one, humid specific heat. From the equation of enthalpy of moisture, the humid specific heat of moisture can be written as Cpm equal to Cp plus W into Cpw. Okay. Next we are going to the specific volume. Specific volume is defined as the number of cubic meters of moist air per kilogram of dry air. Okay, number of cubic meters of moist air per kilogram of dry air, meter cube per kg. Okay, so we have seen the properties such as dry bulb temperature, wet bulb temperature, dew point temperature, specific humidity, humidity ratio, relative humidity, and then enthalpy. Okay, next we are going to see how these properties are graphically represented and how it is associated. So this graphical representation of the psychrometric properties in a graph, we calling it as a psychrometric chart. So the psychrometric chart is nothing but it graphically represents the thermodynamic properties of the moist air. So standard psychrometric charts are bounded by dry bulb temperature line and the vapor pressure or humidity ratio. So we'll be having dry bulb temperature line in abscissa and the vapor pressure or humidity ratio in the ordinate, which means dry bulb temperature in x-axis and humidity as well as humidity ratio and the vapor pressure in the y-axis. Okay. So here the graphical representation of psychrometric chart. Okay, in this you can see the dry bulb temperature increasing from x-axis line in this line, and then you will be having a humidity, specific humidity or humidity ratio will be having here, and then this line represents the this here you will be having the straight line, you will be having partial pressure of water vapor. Okay, here this will be the line of constant enthalpy. Here you can see the line constant enthalpy lines. This curve is known as saturation curve. Okay, this line we calling it as lines of constant specific volume line. This dashed line we calling it as constant specific volume line. Clear? This one will be the humidity, excuse me. So this line we calling it as a percentage relative humidity. It is expressed in percentage. This line, this blue color line, here it is not given. It is the relative humidity which is denoted as percentage. Say for example 30, 50, 60. Okay, this line we call it as a dry bulb temperature, and this one is a, this curved line is a relative humidity. Then this slanting line we call it as line of constant enthalpy value. Then this dotted line is a line of constant specific volume. So this psychrometric chart gives the entire thermodynamic properties of the moist air. Okay, so you may heard of psychrometer. What is my psychrometer? It is nothing but an instrument capable of measuring the psychrometric state of air is called as a psychrometer. So the instrument which is used to measure this psychrometric state of air, we calling it as a psychrometer. So two types of psychrometers are commonly used. One is a sling psychrometer, which is widely used for measurements involving room air and other application. The other is a aspirated psychrometer. In this, the psychrometer remains stationary and small fan blower or syringe which is used to across the thermometer bulbs. Other type of psychrometric instruments are Dunmore electric hydrometer, DPT meter and hygrometer. That's all for the psychrometric properties. Okay, next we are going to see psychrometric process. So so far we have seen about the properties of air, psychrometric properties of air, which is used for air conditioning system. Now we are going to see the psychrometric process. So first one is a sensible cooling process. So in this psychrometric chart, if you see that point O to A, so here the dry bulb temperature will be increasing. You will be having the dry bulb enthalpy at point O will be higher than the enthalpy at point A. Okay, the enthalpy is reduced from HO to HA. So this process we calling it as a sensible cooling process. It is nothing but when an air is passed through a tube. When air is passed through a tube, when it is cooled by a coil surrounded it, or when it is cooled by a coil which passes the cold temperature. So when the air strikes that coil, the temperature is getting decreased. So we calling it as sensible cooling process. So here the enthalpy of the air is getting decreased and the air gets cooled. It is a sensible cooling process. So next one is a sensible heating process. The same thing when we keep a heating coil inside while passing the air. So the enthalpy of HO air will be increased from HO to HB. So this type of process we called as a sensible heating process. Okay. Next we are going to see cooling and dehumidification process. So in this process, when air is passed through a coil, cooling coil, it gets cooled At the same time, the humidity present in the air is removed by dehumidification process. So here we achieve both cooling and dehumidification process at a single pass of air. When an air is passed through a tube, the cooling coil provides cooling. At the same time, the humidity present in the air is getting reduced, dehumidified. So here it represents the cooling and dehumidification process. So next one, heating and humidification process. When the air is passing through a heating coil, the air gets heated. During the time of heating, the humidity present in the air may be getting decreased. So to increase the humidity of air, we are providing spraying a moisture of air. It's a moisture of water, spraying the water to increase the humidity. So here we achieve heating as well as humidification. So the line represents the temperature is getting increased as well as humidity also getting increased. So WO to WD. So heating and humidification process is achieved at the same time. This is a mixing of adiabatic mixing of two air streams without condensation. So without condensation process, we are going to mix two adiabatic streams of air.